Welcome everyone to our lesson on parts of an algebraic expression. We're also going to talk about in and out tables with expressions, but we're going to start off with parts of an algebraic expression. So just like a sentence has different parts, sentences are made up of words, and those words might be nouns, they might be verbs, they might be adjectives. Expressions are very similar. So kind of the equivalent of words in an algebraic expression are the terms. So the terms are the parts of the expression separated by addition or subtraction. So in this case, we have 5p is a term and 4 is a term. So each part separated by addition or subtraction is called a term. Those are kind of like the words. Now, each of these terms may have variables, coefficients, and or constants. So let's look at our first term here. We have 5 times p. So let's start with the p, the letter. The letter is a variable that can represent one or more numbers. And that's always a letter, and it can be any letter. Now that number that's next to the p tells us how many of that variable we have. So in this case, we have 5 p's or 5 times p. Now since this is with the variable, now remember the stem co means with, and the 5 is with the variable, so that's how we know it's a coefficient. So this 5 is our coefficient for the term. Now we also have terms that do not have variables. If you have a term that does not have a variable, well, it's going to stay constant. So in this case, the 4 is a term that is a constant. Let's go ahead and look at some examples on identifying parts of an algebraic expression. So we're going to start off with the algebraic expression 5x plus 13. We're going to identify the terms, coefficients, and constants. Now I like to set up this table. I think it really helps keep your work organized. Alright, so the first thing I'm going to do is after I write down the expression, I'm going to box up the terms. I think it makes it easy to see if we do that. So we have 5x, and when I box up the terms, I also like to box up the operation, either addition or subtraction. And addition means we have a positive term. If we had subtraction, it would mean we have a negative term. Alright, so let's start with the 5x. That's our first term, so I'm going to write it here. Now each term is going to either have a coefficient or it's going to be a constant. You will never have both for any one term. Alright, so we do have a variable, so that means we have a coefficient. The coefficient is the factor with the variable, and that tells us how many x's we have. We have 5 x's. And since we do have a variable, it is not a constant, so I just put a line in that spot. Alright, so that takes care of 5x. Let's move on to 13. Now obviously 13, there is no variable, so that means there is no coefficient and it is a constant. Alright, and that takes care of both of our terms. Now in big ideas, they're going to not create a table like this. They're going to have the terms, coefficients, and constants like in lists. So the final answer for terms would be 5x comma 13. For coefficients, you would just have 5, and constants you would have 13. Right? And this is how you would see it in big ideas. Alright, let's go ahead and move on to our next one. So our next expression is 4y squared plus t plus 3. So let's go ahead and box up the terms. So we have 4y squared, we have a positive t, and we have a positive 3. Let's start with our 4y squared. Alright, so we do have a variable. It also has an exponent, but we really don't need to worry about the exponent at this point. So the exponent is really irrelevant. What we're looking for is the factor with our variable, which is 4. 4 is our factor, that is our coefficient, and since there is a variable, this term does not have a constant. Alright, now on to one that's a little more tricky. We have t here. Now every variable has a coefficient which tells us how many of that variable we have. Now in math, we don't write, when we're multiplying by 1, we do not write the 1 in front. We just kind of leave it off. But really, there is a 1 here. We have 1 times t. What is 1 times t? 1 times t is just t. So in math, we try and simplify it and just write the t by itself, but really there is, you could think of it as an invisible coefficient. It does exist. So we would say we have 1t, so the coefficient for this term is 1, and there is no constant. Alright, so keep that in mind as you're working with these terms. Alright, finally we have a term of 3. There's no variable, so there's no coefficient, and it is constant of 3. Alright, so again, big ideas would write these as a list. So as a final answer, we have 4y squared, comma t, comma 3 for our terms. Our coefficients are 4, comma 1, and our constants are 3. Our constant is 3, I should say. Alright, let's try a couple on your own. Go ahead and try this one. Alright, so we have terms of 15, 3w, and 1/2. Coefficient of 3 with the w. We have constants of 15 and 1/2. Notice the only item with variables are the terms. Coefficients and constants are always just numbers. Here's another on your own for you to try. Alright, so in this case we have a z squared and we have that invisible coefficient. We have exactly 1 z squared, because remember, 1 times z squared is equal to z squared. So we do have a coefficient of 1 in front of that z squared. No constant there. And then for the term 9z, we have 9 z's. Our factor is 9. There is no constant. And then writing this in a list form, we have z squared comma 9z for terms, coefficients of 1 and 9, and constants, there are no constants, so that's none. Alright, so that's kind of the parts of an algebraic expression. The last thing I want to cover are in-out tables. Alright, so here we have an input-output table. So we have in of 1, out is 4, in of 3, out is 6. So in this case, we have a rule of plus 3. So 1 plus 3 equals 4, and 3 plus 3 equals 6. So what would the out for 8 be? Well, if we add 3, it would be 11. And if the out is 20, we actually have to go in reverse. So what plus 3 equals 20? That would be 17. Now that we're doing algebra, we could actually put this in terms of algebra. And how we do that is, well, we could say the in is our variable. It could be any variable. So I'm going to just use x for now, but again, it could be any variable. Now, what would our out be? Our out would be, well, whatever x is, we're going to add 3 to it. So in the out, we have our algebraic expression. So this is saying for the in, we're going to have x is equal to 1, x is equal to 3, x is equal to 8, and x is equal to 17. And when x is equal to 1, we're going to substitute in 1 for x, and 1 plus 3 is 4. And for x is equal to 3, we're going to substitute in 3 for x, and we're going to get 3 plus 3 is 6. And you get the idea, 8 plus 3 is 11, and 17 plus 3 is equal to 20. So we're taking that in-out table that you've done before, which really is algebra, and we're writing actual algebraic expressions with that. So let's go ahead and look at a more open-ended example. So if we're asked to complete the table, and we have an in of x and an out of 2x plus 1, that means for the in of 1, that means we want to know what is this when x is equal to 1? Well, that means we have 2, and then in place of x, we're going to put 1 plus the 1 here. And now we need to remember our order of operations and go ahead and evaluate. So there's nothing inside parentheses, no exponents. We do have to multiply and divide first, so we have to do 2 times 1 is 2 plus 1. Now we can add and subtract, and we get 3. So in our in, whenever we have a 1 on the in, we get out a 3, and this algebraic expression is our rule. Let's look at if we put 3 as our in to x. So if we put 3 in for x, we have 2 times 3 plus 1. 2 times 3 is 6 plus 1 is 7. And finally, what if our in is x is 5? That means we put 5 in for x, and we just use the order of operations to evaluate, and that would be 11. So in this in-out table, we have in of 1 out of 3, in of 3 out 7, and in 5 out 11. So go ahead and try this one on your own. So we want in, what is this, out, when y is 2. So you're going to plug in 2 for y and evaluate. So go ahead and fill in this table. Alright, so you should have gotten in 2 out 7, in 6 out 27, in 8 out 37. Now just a heads up in big ideas, they do like to write their tables horizontally. So you may see the in-out table like this, where the in is the first row and the out is the second row. So just a quick heads up on that. Alright, that'll do it for today's lesson.